Here we are looking at the probability of compound events, and a compound event is just two or more events linked by the word and or. It's important to make note of whether the events are mutually exclusive or whether they are overlapping. Overlapping does exactly what it sounds like. It means that they have outcomes in common, whereas mutually exclusive means that you can't have both of them happening at the same time. So that's why you see on the screen that the probability of mutually exclusive events, for example, if I'm trying to find the probability of A or B, I would find the probability of A, find the probability of B, and add them together. Whereas with the probability of overlapping events, I add them together, but then I need to subtract away any of the probability of them occurring together. So, for example, I have a spinner that has 20 equal-sized sections numbering from 1 to 20. What is the probability that I will spin a 2 or a 5? Well, I can't spin a 2 and a 5, so those events are mutually exclusive. So the probability of spinning a 2 is 1 over 20, and the probability of spinning a 5 is also 1 out of 20, and so the probability of 2 or 5 is 1 over 20 plus 1 over 20, which is 2 over 20. Oops. Which reduces to 1/10. And certainly, if that was a little bit more writing out the process than you needed, write down what you need. I want to make sure that I'm showing enough so that everyone can catch on to what's happening in this lesson. So in part B, what is the probability that I spin a number that is a multiple of 2 or 5? Okay, so multiples of 2 would be 2, 4, 6, 8, 10, 12, 14, 16. Oops. 18 and 20. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the probability of a multiple of 2 is 10 out of 20, or 1/2. Multiples of 5 are 5, 10, 15, and 20. So the probability of a multiple of 5 is 4 out of 20, or 1/5. But these events are not mutually exclusive. I have numbers that are multiples of 2 and 5. And that's 10 and 20. So the probability of, and, I'm going to abbreviate, is 2 out of 20, which is 1/10. So finally, if I'm using the formula that you had at the beginning of, in the last screen, the probability of a multiple of, that was weird, multiple of 2 or 5 would be this probability, which was 10/20ths, plus this probability, which was 4/20ths, minus this probability, which is 2/20ths. And when I simplify that all out, I have 12 over 20, which reduces to 3/5. Similar example, suppose I roll a standard number cube. What is the probability that I roll an even number or a number less than 4? Okay, so probability of an even on a standard number cube, there's 2, 4, and 6, so that's 3 over 6, which is 1/2. Number less than 4, so probability of, I'm going to just abbreviate it as x is less than 4, and that is 3, 2, 1, so that's also 3 over 6. But these events are not mutually exclusive. I have even numbers that are less than 4, namely 2. Okay, so the probability of my and is 1 over 6. So then for part A, the probability of even or less than 4 is 3/6 plus 3/6 minus 1/6. And so that is 5/6. In part B, what is the probability that you roll a 2 or an odd number? 2 and odd numbers are mutually exclusive, so this time all I have to do is find those two probabilities and add them together. So for part B, the probability of rolling a 2 is just 1/6. The probability of rolling an odd on a standard number cube, there's 1, 3, and 5, so that's 3/6, which reduces to 1/2. Therefore, the probability of 2 or odd is 1/6 plus 3/6, which is 4/6, and that reduces to 2/3. We're also talking about independent events versus dependent events. And independent events are such that the probability of one happening has no impact on the probability of the other. For example, if I have 2 coins and I'm flipping one coin and then flipping the other, flipping heads on one coin does not affect the probability that I will flip heads on the other coin. They are independent events. So when I'm trying to find the probability of 2 independent events, I find each separate probability and then multiply them together. So in problem 2, you see that I'm rolling a red number cube and a blue number cube. Those events are independent. And so what is the probability that we will roll a 3 on the red cube? That is 1 out of 6. And then the probability that I will get even on the blue cube, that's 1/2. 3 out of 6. So, probability of 3 on red and even on blue is 1/6 times 1/2, and ladies and gentlemen, you must overcome your fraction fears now or never. 1/6 times 1/2, straight across the top, straight across the bottom, that's 1/12. Pause the video for the your turn below. In problem 3, we are looking at these mahjong tiles, and notice in this problem we are choosing a tile, replacing it, and then choosing again. So we have 15 tiles. So I'd hope that you'd realize any probabilities we find will probably have a denominator of 15 to start out with. So probability of choosing a dotted tile, well, how many dotted tiles do I have? 1, 2, 3, 4. So 4 over 15. So I take that dotted tile and I put it back, and then I want to find the probability of a dragon tile. Well, I have 1, 2, 3 dragon tiles. So the probability of dotted and then the dragon is 4/15 times 1/5. And that's 4 over 75. Here, we're dealing with a dependent probability because I am selecting without replacement. But the math is still the same. I find the probability of one event, I find the probability of the other event, and then I multiply them together. So I am finding the probability that I choose a dotted tile. So probability of dotted, there's still 15 tiles, there's still 4 that are dotted, so 4 out of 15 is my probability of pulling a dotted tile. But since I am not replacing that first tile, I have to consider this bag of tiles, if you will. Now there's 14 tiles. And so how many dragons? There's still 3. So probability of then dragon would be 3 out of 14. And now the probability of dotted then dragon is 4/15 times 3/14, and you could multiply that straight across the top, multiply that straight across the bottom, or you could realize that you can cross-reduce and then multiply. So 2 times 3 is 6. Oh, I've got some more cross-reducing I could do. I almost missed it. So it's 2 over 35. Last example, I have freshmen, 2 sophomores, 4 juniors, and 5 seniors, and I'm choosing 2 names at random from a hat so that they will read their essay. And what I'm trying to find the probability of is that a junior and then a senior will be chosen. So I have a probability of a junior is 4 over, how many students are in this bag? That's 9, 10, 11, 12. So that's 1/3. And then to find the probability of then senior, well, I have 5 seniors, but now I only have 11 names left in a hat. So the probability of junior, then senior, is 1/3 times 5/11, which is 5 out of 33.